So, how do you prove you created something, a piece of digital art, some code, a song, without having to plaster your identity all over the internet? Well, today, we're diving into a really fascinating system built on the Solana blockchain that lets you do exactly that. And it uses a type of cryptography that, honestly, it feels a little bit like magic.
And at the absolute heart of this system is something called a zero-knowledge proof. It sounds, well, impossible, right? But here's the best way to think about it. Imagine you know a secret password to a clubhouse. A zero-knowledge proof is like being able to convince the bouncer you know the password without ever telling them what it is. You prove you know the secret while keeping the secret, well, secret. This is the cryptographic engine that makes this entire thing possible.
All right, so how are we going to tackle this? First, we'll look at the big picture, the digital blueprint of the whole setup. Then we're going to zoom right into its cryptographic core, the zero-knowledge heart. After that, we'll see how it's actually built to work on the blockchain, watch it go from a simple prototype to the real deal, and finally, we'll look ahead to where this amazing tech could be going next.
Okay, first things first, the digital blueprint. The really key idea here is something they call a local first approach. And what that means is pretty much all the important stuff, the creating, the signing, the data, it all happens on the author's own computer. It stays private. Only the final, absolutely crucial proof of ownership gets sent out to the public, unchangeable ledger of the Solana blockchain.
You know, what's so cool about this setup is the balance it strikes. You've got a pretty standard React front end for the user and a super powerful Rust backend handling everything locally, right down to their private database. But the magic? The real game changer is that on-chain layer. That's Solana. It's like a global public notary that can confirm your proof is valid without ever getting a peek at your private data. This separation of a private workspace and a public verifier, that's the secret sauce.
So now that we've got the lay of the land, let's dive into that cryptographic core. This is where the actual zero-knowledge proof gets made. It happens inside what's called a Groth16 circuit, which is just a very specific and very efficient type of ZK system. You can basically think of it as a logical maze, one that's designed to prove you made it to the end without showing anyone the path you took.
Okay, the best way to think about one of these circuits is like a recipe. You have your public inputs, those are the ingredients listed on the box for everyone to see. Then you have the private witness. This is your secret ingredient, your family's secret technique that makes the dish amazing. And finally, you have the constraints. Those are the steps in the recipe. The circuit just checks that your secret technique, your private witness, correctly used all the public ingredients to get the right result. And it does all that without you ever having to reveal your secret.
So you've just made this brilliant private proof on your computer. Fantastic. But now for the million-dollar question. How in the world do you get a public blockchain like Solana, which knows absolutely nothing about your secrets, to actually understand and verify it? That is the big engineering problem to solve here.
And here is the genius solution. See, verifying these proofs involves some really specific, really heavy-duty math. Trying to do that with normal code on a blockchain would be painfully slow and ridiculously expensive. So Solana has this built-in cryptographic superpower called the Alt-BN128 precompile. Think of it like a specialized, hyper-optimized calculator that's part of the blockchain itself. And it's designed to do just one thing: run this heavy math incredibly fast. It's the bridge that lets the private, off-chain world talk to the public on-chain world.
Okay, so now we shift gears from theory to the real world. You know, a complex, trustless system like this doesn't just spring into existence. The developers started with placeholder code, what they call stubs, to basically map out the whole structure. Then they went back and systematically replaced every single one of those placeholders with the real working cryptography.
And I love this quote from the developers. It really shows a commitment to not just building this, but making it understandable. For us, it's the signal that we're moving past the blueprints and into the actual nuts and bolts implementation.
And here's the proof in the pudding, literally. You can see the evolution right here in the files. Look at that verify.rs file. It goes from a dummy placeholder to making a real call to that Alt-BN128 engine we were just talking about. The verifying key.rs file, it stops holding junk data and gets the actual crypto keys. And on the user's side, the code is updated to generate real proofs, not fakes. This is exactly how you build a system you can trust, one verifiable piece at a time.
All right, so once you have this rock-solid system for just proving authorship, what's next? What else can you build with it? This is where it gets incredibly powerful, because that proof of authorship, it's not the end goal. It's the foundation for a whole new world of tools for creators.
So the first new feature is a publish instruction. It lets an author take that verified on-chain proof and officially link it to a public digital thing, say an NFT they just minted, or a file they put on a decentralized network like IPFS. It's the moment you connect your private proof to your public creation.
Now this second feature, this is where the ZK magic just gets awesome. With a set royalties instruction, an author can commit to a royalty split for their work. But here's the kicker. Because it's all zero knowledge, they can prove on-chain that a fair royalty agreement exists without ever revealing who gets paid or how much they get. It lets collaborators trust the deal's locked in, but with complete privacy. How cool is that?
So, the big takeaway here is that this isn't just a cool idea anymore. You can see from the status table the whole thing is up and running. The on-chain verifier is live. The prover that creates the proofs is integrated. The publishing and royalty tools are built. This is a real, end-to-end, fully functional system.
So where does all this go? I mean, proving authorship is a huge first step, but it's really just a beginning. The vision for this technology is, well, it's much, much bigger. It's about rethinking the foundation of digital property itself.
And this roadmap is seriously ambitious. We're talking about expanding from just authorship to full-on digital property rights, where your ownership is a token you can transfer. Imagine integrating this with decentralized identity systems, or being able to handle complex legal agreements, like software licenses, all with the unbreakable privacy that zero-knowledge proofs give you. This is a building block for a totally new kind of digital economy, one that's more private and puts creators first.
And that leaves us with this one last really mind-bending thought. We've always tied ownership to a public identity, but if you can cryptographically prove, beyond a shadow of a doubt, that you own something, an idea, a piece of art, whatever, without ever revealing who you are, it totally changes what ownership means. What does it mean to own something when the proof is absolute, but the owner can remain a ghost in the machine? That's the powerful question this tech leaves us with.